Okay, today we are going to solve this directional derivatives word problem. Right off the bat, after reading it through, you can see that we are working with a volume problem, okay? So the first thing we can acknowledge are a couple rules here. So V equals X times Y times Z. From there, we can also see that we can build the basis for the equation that we'll use to solve this. So what we'll do is we'll get the partial derivative with respect to volume of x times the rate of change, which we are already given very nicely, which in this case is dx. We'll just represent it as dx for now. We'll plug it in later. Plus partial derivative of y dy plus partial derivative of z. Oops. dz. Okay. So right off the bat, we already know our dx, dy, and dz. It is given in the word problem. It says the dimensions are increasing at a rate of 2 centimeters an hour for x and y coordinates, and decreasing at a rate of 1 centimeter an hour in the z direction. Okay, so for now, we're just going to calculate our partial derivatives here with respect to the volume. So first we'll find the x. Of x, y, z equals, when you derive this equation right here, with respect to x, you're only canceling out the x, or it equals 1. So essentially it just cancels out. So we're left with y and z. Now, repeat that process with respect to y now. Derive y that equals 1, and we are left with x and z. Next, we will derive z. And when you derive z, you're left with x and y values. Okay. From here, we can just plug that into the equation. Let's see. Move these out of the way. So our equation, we'll just copy it, but plug everything back in. So we have yz times dx plus xz times dy plus xy times dz. All right. From there, we can plug a couple things in, actually. So we do know the rates, and we are also told that we are also told the final dimensions at this moment, which are 5 centimeters, 6 centimeters, and 8 centimeters. Those will actually be plugged directly into our x, y, and z values that we have here. And from there, you can solve. So let's plug those in. Y is 6 centimeters. These are all relative, so this is x, this is y, this is z. Z is 8 times dx, which we are given as a positive 2 centimeters an hour. Okay, plus x, which is 5 times z, 8 times dy, which in this case is also 2 centimeters an hour, plus x, 5 times y, 6 times dz, which it says is decreasing. That is important to note. So it would be negative 1. Okay, from there we can solve on our calculator. So we have 6 times 8 times 2 plus 5 times 8 times 2 minus 5 times 6 times negative 1. Should have put a plus sign in there. You don't want to add them. There we go. Hold on. We're having some technical difficulties here. So we are given 176 minus 5 times 6 times negative 1. So that's minus 30. That is 146. And that is our answer.